In this video, we're going to learn about closure. If you don't yet know about the call stack and functional programming, I recommend watching those videos first. In Pixar's animation Coco, there are souls living in the land of the dead. They can exist in the land of the dead as long as someone in the living world remembers them. The only person in the living world who remembers Hector is his daughter Coco. If Coco dies or forgets him, Hector's soul will be garbage collected even in the land of the dead.
What are you talking about all of a sudden?
If you think in relation to this story, you can easily understand the concept of closure. We will go over this together with the JavaScript example on the Notion page linked in the pinned comment. If you've seen this video about the call stack, you would know that when a function is executed, the function and the information related to its execution is placed in this space called a call stack. First, let's look at this function called Hector. As you can see, another function is declared as an inner function within the Hector function, and this inner function is returned as the result of executing the Hector function. Now let's move to the point where the Hector function is executed. Let's assume this call stack is the world of the living, and Hector is alive while the Hector function is running. I mentioned that the stack frame of the call stack also includes the local variables and parameters of the function. This spirit variable is a primitive type string, so it's stored in the stack too. If it were a reference type, it would be stored in something called heap. Then when this function is finished, they are all removed from the stack. Generally, local variables and parameters of a function disappear from the memory as soon as the function finishes. Things owned by a deceased person do not need to exist anymore. Yet, there is one person in this world who still remembers Hector. This Hector function, during its lifetime, had returned its inner function like this. It's possible because functions in JavaScript are first-class objects, as we have discussed in the functional programming video. This returned inner function refers to the spirit variable, and it is stored in a variable called Coco like this. So, the daughter function in this Coco is holding the internal variables of the already ended father function.
But at this point in the code, Coco hasn't yet been executed, so she is not in the world of the living, right?
Let's skip over that part. Not everything lines up perfectly with the metaphor. Anyway, because there's a function that refers to the spirit variable isn't deleted but moved to the spirit world, the heap. In the heap, the garbage collector periodically collects forgotten souls, that is, data that isn't referred to anymore. As long as this function stored in the Coco variable remains in the program, Hector's soul doesn't disappear. Then, like this, when the function also loses its reference, Hector's soul is now collected during the next garbage collection.
So, closure is about the ghost of a function that has finished running.
Yes, although it may seem like a complicated concept when you hear it like this. In fact, it's a principle that we've been using unknowingly when we code. If you're a developer using JavaScript, you might have written a code like this. Let's examine this function called delay_log, a function that prints a message given as a parameter into the log after a given time as another parameter. Right after the delay_log function is executed, its information is set to disappear from the call stack. Not only the local variables of the function, but also parameters like these two are set to be deleted in standard cases. But if you run the code, you will see that this string is printed after a second. This is because, through the closure, this parameter was maintained in memory even after the function was executed.
I've been using it without much thought, but turns out this was closure.
This code was also the last example in the functional programming video. It was an example of a high-order function that receives two callback functions and returns their composition. Because the inner function that the compose function returns refers to the two parameters of the compose function, even after the point when the compose function has finished running, it's that the double function and add_one function that were put in as arguments work internally to return the result the developer intended. I use JavaScript because it runs easily in the browser, but closures can be utilized in any language where functions are first-class objects, nested functions are allowed, and lexical scoping is supported. I covered first-class objects in the functional programming video. Nested functions mean that you can declare other functions within a function. Let's learn about lexical scoping with the next example. Lexical scoping refers to how the range of variables that a function can use is determined by where the function is declared. In this example, the inner function is declared inside the outer function. A function can access not only the variables and parameters given to it, but also the variables located outside of its declaration. So like this, it can use the local variables and parameters of the outer function surrounding it, and even the variables in the global scope on the farthest outside. On the contrary, the outer scope cannot reference the variables in the inner scope. It's like a tinted car, where you can see the outside from the inside, but you can't see inside from the outside. Even when the internal function comes out like this, it retains the lexical scope of its declared location. That's why it can successfully output these values even when executed from outside.
So, is it similar to how a person remembers the vibe of the neighborhood where they grew up and their country's culture, even when they go to a foreign land?
Yes, thinking in that way will help you to easily understand and remember the concept of closure. To wrap things up, let's do something interesting using closures. We are going to make a counter that prints a number increasing by a set value each time it is executed. Many of you might think of a code that utilizes a class like this. You might set an initial value as a field of the class and decide the value that will increase each time as an argument of the constructor. You create and use an instance as needed like this. Since each instance contains the values of the fields, you can continue to use them as long as you do not replace them with null. If you open the developer console in your browser and run it, you can see the code working as intended. If you write this code using a closure, you can make it much more concise. Like this, the create counter, an external function, is returning an internal function. You can see that the returned internal function uses the local variables and parameters of the external function like field instances. The benefits of writing code like this with closures aren't just that it simplifies the code, it's also that the values of this count and add value stored in the lexical scope are hidden away and can't be accessed in ways other than running the function. This means that you can hide these in the childhood memories of the returned inner function, so that the data cannot be viewed or modified from the outside. Therefore, in languages like Python that do not have a private field feature, or in other words, in language that can't fully hide fields, this closure can be very useful. Also, less memory is required compared to the class-based approach, so you can find cases where it is more advantageous to write simple functions like this counter as a closure. Today, we saw how closures work. In the next video, we'll look at currying, another subject that ties in with functional programming. So, see you in the next video.